If you have any question, please ask me.
No, Ramana, I have no questions.
Okay, okay. What about Solai Ramkumar?
Yeah, no from my side.
Okay,
No,
okay,
Ramana. No.
okay, okay, fine, fine. So, let me. So, I think my screen is visible to you, right?
Yes, Ramana.
Yes. Okay, fine.
Yes.
Okay. Anjali Singh, you're working in which domain?
Actually, I'm a release manager. I'm working with Verizon.
Okay,
So I have to work with different teams. One of the team is SRE, like infra team.
okay,
So basically, we have this Jenkins jobs to run whenever the release goes, and then we have other things related to infra. So that's the reason I wanted to understand how these things work.
okay, okay.
So majorly, I work with a developer,
Mm-hmm.
the validation team, and the infra team.
Okay,
Yep.
fine. Let me connect to the EC2 machine. Okay, fine. So, yesterday I gave you one task, one assignment. Did anyone try this one? Fetching, Git fetching. Anyone tried that one? We need to fetch the uh, updates from the GitHub, and we need to manually merge those changes to the local repository. Did anyone try this one? Or
No, I haven't tried.
okay, okay. So okay, I'll show you how to do that fetching. So first of all, okay. So if you see, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, I have 10.txt. I have files, all the files in my local repository, right? So now what I'll do is, let me go to GitHub. So here, I will create one more file. Let us take 11.txt. This is the file 11. Okay. Now let me commit these changes. Now I have 11.txt in my remote repository, right? So what I'll do now, I will fetch this 11.txt. Okay, because I have all the files except 11.txt on my local repository, right? So here if you see, except 11.txt, I have all the files. Okay. Now what I'll do, I'll simply fetch the changes. Okay, git fetch origin from master branch, right? Or else you can simply give the https link here. Simply you can give the https link. Yesterday we tried that one, right? We fetched the latest changes by using the https link. Or else you can simply use origin master. here you can see this is origin. Origin means this is the remote name. Okay, like for example, if you have the multiple repositories in your remote repository, in that case you can just customize this remote name. But by default you will get the origin as your remote name. Okay, so I didn't change this default name. Okay, so now if you fetch that changes, you can see those changes will be added to the local repository, but you cannot merge those changes to the working directory, right? So let me fetch this changes now. Now it is asking the username. Let me open this one, GitHub token. Paste it. Oh, sorry. Mouse is not working properly. Let me copy once. Oh, now let me copy the token. See now I'm able to fetch the changes. Okay, from the this is the remote branch master. From master to fetch head. Fetch head is the local. Okay, your local repository. Or else you can see this is the origin master. Okay, so now let us see whether I have the 11.txt or not in my local. Let us see ls. See, I don't have 11.txt here. Okay, now first of all let me check whether I fetch the changes or not. Let me check. How we can check? Just use git log command. Okay, give remote name, that is the origin. Okay, slash we fetch the changes from the master. So use this git log command so that you can see the commit. Okay, see, create 11.txt. This is the commit, but this commit is, I'm not able to see this commit in my local repository, right? Okay, so what I have to do is, now I need to merge this commit manually. Okay, how I can do that? Simply one command, git merge. Okay, give origin master. Okay, so whenever you use this command, what it will do, first of all it will check the remote name. Okay, in that remote name it will check the master branch and it will check the commits in that. Okay, so if there is any latest commit, that commit will be merged. Okay, let me enter it. See, one file changed, one insertion. Okay, 11.txt. Okay, so let me check list out ls. Now 11.txt is added to the working directory. So like this you can do the fetching. But whenever you do pulling, what it will do, it will simply download the file and it will automatically merge that file to the working directory. Okay, so that is the difference between git pull and git fetch. Okay, so I can say git pull, we can say let me open the notepad. So I can say git pull equal to git fetch plus merging. So can I write like this? Because git pull is automatically merge it. After downloading the file, it will automatically merge it. So whenever you when the interview asks you what's the pull, what's the fetch, just you can say like this: git pull is a combination of fetching and automatic merging. You can say simply like this. Okay, so I think you guys understood what I'm saying. Do you have any questions in pulling and fetching? Anyone?
No, Raman.
Okay. Okay, so now we will go to branches like merging. Where we left yesterday here. I think yesterday I have explained merging, right? Git merge and git rebase. So can I explain it once again, or shall I?
Yes, Mama. Yes, just speak.
Can I explain it once again?
Yes, Mama. Yes, Mama. Please.
Okay, fine. Okay. So see, if you see git merge, see there are two methods. Two methods for merging the changes. One is git merge, other one is git rebase. Okay. So if you see the git merge here in this diagram, this blue indicates the master branch, and the green indicates the feature branch. Okay. So I have created the feature branch from the first commit of the master branch. Here you can see. Now here on my feature branch, the developer is working. Developer is making some changes to the feature branch. Okay, but while he is making some changes to the feature branch, this branch, master branch, is moved forwarded to two commits. See, this is one commit, this is two commits. See, this branch is it's forwarded, two commits forwarded, right? Now what this feature branch will do, this developer A will do, he will merge his changes. What are the changes he has done in his branch? He will merge to the master branch. Okay, what will happen? This feature branch will automatically create one commit. This commit is the resulting of the merging. So whenever he merge his feature branch with the merge, it will create one new commit on the master branch. Okay, and this commit will have the features of the feature branch. This is the feature branch, right? So this commit on the master branch will have the features of the feature branch. Okay, so this is what merging. Or you can also merge master branch with feature also. That can also you can do, because whenever you need the latest changes from the master branch, in that case you can simply merge master branch with the feature branch also, or you can also merge your feature branch with master branch also. Both the things you can do based on your need, based on your requirement. Okay, so and also this is the merging, but we will see during the merging what are the conflicts we are getting. Okay, with this diagram you can simply say that we can able to merge it, but whenever you do, actually we will get the conflict here. If you see this diagram, you will get the conflict, because I already told you yesterday's class, in the yesterday class. So this feature branch doesn't have the latest of this master branch. Here these are the two commits. These two commits are not there in the feature branch. So whenever you try to merge this feature branch with the master branch, it will give you the conflict, because this feature branch doesn't have the latest changes of the master. Okay, so it will give you the conflict. But till this slide you don't focus on the conflict, just you focus on the merging. So what is the merging? So how we can do the merging? So you just focus on those things only. Okay, I will explain you the conflicts also. Okay, practically I'll show you what is the conflict. Okay, so this is what merging here. Okay, now if you go to rebasing, see this is my master branch. Okay, now I'm creating a feature branch out of this master branch. Now from where I'm creating the feature branch? From commit B. See here, if you see this diagram, my feature branch is created from commit B. Okay, now this is my feature branch. Okay, now after some time what I'm thinking is, so I need some features from the master branch, because after creating the feature branch from the master branch, commit B, but here the master branch again, it has one more latest commit after creating the feature branch, but this commit, this latest change, we don't have in the feature branch. This feature branch doesn't have the latest changes, because this feature branch is created from B. Okay, this commit C is on master, so this commit C is not on feature. So we need this commit C on feature branch. We require that changes. So in that case, what this feature branch will do, it will simply rebase this master branch with the feature branch. So here if you observe rebase means you are changing the base. Okay, previously if you see the first one here, the base for the feature branch is B, commit B. After rebasing, the commit has been changed, right? Now the base is C. For the feature branch, the base is C. So I just changed the base for the feature branch. That means, see, I have created feature branch from B. Now the developer is working on this feature branch and he just committed one more, that is the E. Okay, so during his modifications on feature branch, master branch is also committed one commit here, C. Okay, but this, see, this one is the, if you can say, for example, the developer is working on any service. Okay, that service requires some additional code. That additional code is in this commit. Okay, without this code the developer cannot work on his feature. So what he has to do, first he needs this code, or he needs these prerequisites for this code. So in that case what he will do, he needs this code at the root of his branch. Based on this only he can work. He cannot keep this commit at the end. Did you get my point? He cannot keep this commit C at the end of the feature branch, because he is trying to modifying his feature branch based on the C. In that case what he has to do, he needs to keep this C at the base of the branch. Okay, from this commit only he has to work. In that case he needs to do rebase. But in case of merging, what he has to do, he don't need this one, he don't need this C commit. Okay, he will simply work from B, root B, and he will do modifications on his feature branch, and he will do some commits on his feature branch, and then he will merge those changes to master branch directly. Okay, so that is the difference, merging and the rebasing. Okay, so when you will use rebasing, whenever you are doing some developing work, whenever you are writing some code, it needs any dependencies, it needs any prerequisites, or it needs anything to write the code from the base. In that case he needs to rebase. So these things will be done in the local, not on the remote, because you know, whenever you do rebasing on remote, you can see this rebasing will not create any commit whenever you do rebase. But if you go to merging, if you do merging feature branch with the master branch, it will create the new commit. So that indicates, see, if there are multiple developers in the organization, so whenever they see these new commit, they can understand, okay, this commit is from the feature branch, so this commit has these kind of changes, so they can understand easily whenever they see the commit. But if you don't see the commit, how they can understand whether they merged it or not? They cannot understand. No one can understand, no one can see that merging, because there is no commit ID. So that's why you cannot do this rebasing on the remote, because the developers will be confused. Okay, so that is what rebasing. Okay, if you see here the differences, okay, this is the original. Okay, the first one is the original. So here if you see the master branch, okay, from B I have created the feature branch. Okay, developer A is working on this feature branch, he has done some changes to the feature branch, he just committed he committed B. Okay, now while he is doing modifications in feature branch, this master branch is also having some latest commits on his branch C and D. Okay, now if I want to do, just for example, I want to do merging, what I will do, I will simply merge this feature branch with the master branch. Okay, now this will create a new commit called G. Previously there is no commit called G, only it will create after the merging. But in case if you see the rebasing, this is the feature branch. Okay, this is the feature branch, Now what I'm doing is I want to rebase it. If I want to rebase it, what will happen? This is C and D, these both changes, what are the changes are there? See, this feature branch is created from B only. It doesn't have the changes of C and D. So whenever you do rebasing, the changes, whatever the changes in the master branch, these changes will be added at the root of the feature branch. Now if you see, this EFG will be here. Now the root will be CD. Now you can see CDEFG. Okay, so this is the rebasing. Did you see any new commit here? You cannot see new commit. You cannot see new commit, but in case of merging, you can see the new commit. Okay, so that's why whenever you working in remote, you simply use the merging. Whenever you're working in local, you can simply use the rebase. Okay, because in your local, you will be only working on your local, right? No one will work on your local, right? So you know whether it's a rebasing or it's merging, you know. But if somebody comes to your local system, if somebody is working on your local system, he cannot understand whether it is rebase or whether it is merging, because he cannot see the new commit there. But in remote, everyone has to see the remote repository. There we need to we need a clear picture. Like it should show the clear graph, Git graph. If there is no merge commit, then he cannot understand whether there we have added the new changes or not. We cannot understand. So that's why in remote always use the git merge, local always use the git rebase. Okay, so if you see, during merging, sometimes you will face the conflicts. Okay, sometimes you will face the conflicts. How you will face the conflicts? I already told you multiple times. See, this is my master branch or main branch. Okay, now I have created one branch out of this master branch. Okay, so this is my feature branch. Let us take feature branch. Okay, now the developer is working on this feature branch. Okay, but while he is working on his feature branch, the master branch moves one step forward. Like it has a latest commit on his master branch, on this master branch. But this change, whatever the change in the master branch, we cannot see in the feature branch because it is created from here, not from here. Okay, so because of this, it doesn't have the latest change. Whenever you do merging with the master branch, you will get the conflict here because you don't have the latest on your feature branch. So this is what the conflict. Okay, I'll show you the practical way how you will get the conflict. Okay, see this one. Okay, here if you see, this is the master branch. Okay, from master branch, from the commit to, okay, from commit to, or instead of showing these pictures again and again, I'll just simply open the terminal and I'll show you how we will get the conflict. Okay, now first of all, let me check on which branch I am. See, this is main branch. Okay, now what I'll do is I'll change feature branch name feature with the feature one. Okay, so git branch and you can just simply give the feature and -m. This name should be feature one. Okay, I'm changing the branch feature with the feature one. Okay, now if you see git branch, now my branch name becomes a feature one. Okay, now what I'll do is or simply do one thing. Let me remove this feature one. Git branch -d feature one. Let me remove that one. Let us create new branch one. So I have main branch only. Now I will create git branch feature one, and I'll create feature two also. Oh no, it is taking only one. Feature one, and again I'm creating feature two. Okay, Now if you check the branches, I have two feature branches. These two feature branches I have created from the main. Okay, because I am in main. Okay, from main I created these two branches. Okay, now what I'll do is, if you see, my main branch have these files. Okay, and also if you check out to the feature 1, okay, here also you can check, it will also have all the files because I created from main, right? Now again I will check out to the feature 2, it will also same files. Okay, now main feature, every branch has same files. Okay, now what I'll do is, first of all I will work on feature 1. Okay, I'm checking out to the feature 1. I have 11. I have these files. Now I will create one file, or I'll just simply change 11.txt. I'll simply change this 11.txt. This is the modification in file level. Let me save this one. Okay, now let me add this to staging area. Let me commit it. Okay, modifying 11.txt. okay, now I have committed. If you see the logs, git logs, see, modifying 11.txt. This is the commit on feature 1. This is on feature 1. You can observe here, this is on feature 1. Okay, now let me clear this screen. Okay, so I have changed the 11.txt. Now what I'll do is, see, currently I am on feature, right, feature 1. Now I will check out to the master main. Okay, now I am on main branch. Okay, git branch, I am on main now. Okay, now what I'll do is, I will simply merge this feature 1 with the main. Okay, so whenever you do merging, so you just simply focus here. I need to merge feature 1 with the main. In that case, you have to first come to main, then only you can merge. Or if you want to merge this main with feature 1, then you should check out to feature 1 first, then only you can merge. Okay, so what I'm doing is, I want to feature 1 to be merged with main. Okay, so now I'm in main branch. Now I will use git merge feature 1. Okay, I'm merging feature 1 with the main. Okay, now enter. See, updating 11.txt, one file is changed, one insertion. If you do ls here, just open 11.txt. see, this is the modification in file level. Now I am able to merge this feature 1 with the master branch. So this is what merging. Okay, now I will show you how we will get the conflict. Okay, if you see, I am in git main branch. If you check the logs, okay, git log -- graph, I want to see the one-liners of the log instead of checking all the unnecessary things. I just want to see the one-liners of the log. Okay, this is simply, you can use -- graph -- pretty equal to one line. Sorry, one line. If you see here, what I have done, see, modifying 11.txt is added, okay, from feature 1. From feature 1, I just added to the main. You can see both the branches here. Okay, head is now on main. That indicates that I'm the latest changes is on main branch. Okay, so now what I'll do is simply what I'll do is, now you understood, right? Feature 1, we have, in the feature 1 we have modified 11.txt that 11.txt we merged with the master branch or main branch, okay, but the feature 2 doesn't have the changes in the master branch. That modification we don't have in that in the feature 2. So in that case, if you try to merge our feature to the master main branch, we'll see what will happen. Okay, so currently I'm in main branch. Now let me check out to the feature 2. Git checkout feature 2. Now I am on feature 2. Okay, now ls, you can see 11.txt, you don't have that change in feature 2. Okay, now what I'll do is simply I will again modify 11.txt from feature 2 branch. Okay, here this modification is from the feature 2 branch. Okay, now let me save this one. Let me add it. Let me commit it. Modifying in feature 2. Okay, you can see the log. See, modifying in feature 2. Okay, now just quit it and clear this one. Now what I'll do is I will check out to the main branch. Okay, now if you see the branch, I'm in main branch. Okay, now I want to merge this feature 2 with the main now. Okay, what I have to do, git merge feature 2. We'll see what will happen. See, I got conflict. Auto merging is not possible. Automatic merge failed. Fix conflicts and then commit the results. Did you understand what the conflict is? Because the feature 2 doesn't have the changes of the latest changes in the main branch. Okay, so we need to fix this conflict. So after resolving the conflict, you need to do commit. Okay, it will create a new commit ID. Okay, after resolving the issue. Okay, so now we will discuss the last concept in the Git. Okay, so with this we can just conclude that Git. Okay, the Git will be completed. I think we have taken a lot of time for this Git. I think I have taken around 18 hours for this session. I think I'm not sure about this. So I think I have explained all the topics. I didn't skip single topic from Git. Okay, and if you attempt any interview, you can easily crack the Git. If any question they ask you from Git, you can simply answer all these things, because I completed all the topics. I didn't skip anything. Okay, so now if you see the Git workflow, see what kind of workflow you are using in your organization. Simply, for example, even though if you are a other department, other domain, not from development team, not from the testing, not from the DevOps, even though if you are from other domain, maybe you can ask your colleagues which kind of workflow they are following in the Git. You can ask. They will tell you whether it is a centralized workflow or whether it is a feature branching or whether it is a Git flow workflow. I'll tell you what these are. Okay, so at least any one of these branching strategies they will follow. Maybe they might not be knowing about all these things, but they will definitely follow one of these. Okay, so first of all, let us see. There are three workflows. The first one is centralized workflow. The centralized workflow here, if you observe this pic carefully, these are the developers or the testers or the DevOps guys or any operations guys here. These guys are directly connected with the central repository, the remote repository. Okay, there is only one branch. The only one branch is a master branch. So everyone will work on master branch directly. They won't have feature branches, they won't have the develop branches, they won't have the release branches, they won't have the hot fix, they won't have the bug fix, they won't have all the branches. They will only have the master branch. All the developers will work on their local master branch they will simply push that changes to the remote master branch, or they will simply pull from the remote master branch. So they will always work on the master branch, only single branch. Every developer will do work on that branch. Simply this kind of workflow will be followed in the small organizations. Let us take if that organization is having around 5 to 10 members in that organization. In that case only they will follow. But most of the organizations, they won't recommend this centralized workflow, because the project complexity, based on the project complexity. If the project is very huge project, then multiple employees will work in that organization. The employees should have their own branch there. Everyone should work on their branches. So we need to merge all the changes. We need to get the refined code, the final code, the production ready code. So in that case, we should have multiple branches. In that case, we should not follow the centralized workflow. Okay. So this is the disadvantage of centralized workflow. We cannot do this. We cannot follow this workflow for the large projects. Okay. Now, if you go to feature branching, in the feature branching, this is one of the, I think mostly medium level organizations will follow this one. Here we will have only two branches. One is master branch, other one is feature branch. For example, let us take there are 10 developers in the organization. Okay. Now every developer will have their own feature branch. Developer A will have his own feature branch. Developer B will have his own feature branch. Everyone will have their own feature branches, and after completing their code on that feature branches, they will try to merge those changes to the master branch. Only two branches will be included here in the strategy of the branching. The branching strategies, we will only use two branches, nothing more than that. Okay, this is feature branch. Okay, and next one is the Git flow workflow. So I think 90% of the organizations are following this one, Git flow workflow. Okay, so I can explain, I can elaborate this Git flow workflow with this diagram. Okay, so I think this will include all the branches. Okay, I think many of the organizations will follow this strategy. Okay, so if you see here, it is indicating with multiple colors. If you see this color, this green, I think I'm not good at colors. Okay, so if you see this green color, this green color indicates the feature branch. Okay, you can have multiple feature branches. Every developer will work on their feature branch. Okay, now whenever he completes his code on their feature branch, that code will be merged to the develop branch. This color, you can see this color is indicating that it's a develop branch. It is a develop branch. This develop branch will have the code from all the feature branches. If this develop branch has the complete code, for example, if you take agile methodology, we will have the sprint concept, right? Sprint. Let us take if the sprint is for 14 days. Okay, after 14 days we need to release our product, we need to release our application. In that case, what we have to do, if my code on the develop branch has no errors, no bugs in that, it doesn't have any error in that branch, then this develop branch will be added to the release branch. This is the release branch. Okay, this release branch, here in this release branch we will specify the version. If you take the sprint 1, we can give the version 1. Okay, because we have released some features in that sprint, so we can give one version for that sprint, for that application. So in this release branch, we can specify the version, and then we'll simply merge with the master branch. This is the master branch. So now it will have version called v1.0. Okay. So like this, from feature to develop, develop to release, release to master. But sometimes you need to add some features immediately. You know, there is no time for uh, developing from feature to develop, develop to release, release to master. We don't have that much time. We need to add immediately. In that case, what we have to do is hotfix branch will be created from the master branch. So we will create the hotfix branch from the master branch, and then we will add some feature, or we will resolve some issues. If you have any issue, still you can resolve those issues from this hotfix, or if you want to do some patching, you can do with this hotfix. Okay, so this hotfix will be, I think, most of the organizations will not use regularly. Rarely we will use this hotfix, because we will do testing on feature branches. Every developer will do testing on feature branches. If everything is okay, then the developer will push that code to develop branch, and again in the develop branch we will do the testing. From that we will send it to the release branch. From the release to, we will send it to the master branch. But before going to the master branch, the code will pass the multiple test cases. So testers will do lot of testers they will do on that code. Still, if that code has any issue, then we will create the hotfix. Or if you want to do some patching, we will create the hotfix. Then we will simply merge it to the master branch. Or if you need extra development work, then we will again merge this hotfix with the develop branch. But remember one thing, hotfix cannot be created from the develop branch. It cannot be created from any other branch. It will be only created from the master branch. Keep it in your mind. This will be created from only master branch. Okay. So this is all about the Git flow workflow. So if you have any doubts till now, please you can ask. Anyone, you can ask me any doubt. After that, we will start the Docker. So this is all about the Git. Okay. So you can ask me any doubt in Git. Not about this session. You can ask me any doubt. Francis, Ramkumar, Solai, Anjali Singh. You can ask me any doubt.
Can you show me that initial password key? I forgot that where is it in the settings.
Password token.
Token, yes.
Yes, okay. So you can simply go to here the top right corner. Okay. You can go to settings here. Okay. Now, if you go to the developer options will be there here at the end. Okay. Click here developer options. Here you can see the personal access tokens. Now you can click the classic mode. Okay. See here it will again ask you. You can select the classic one. Okay. It is asking the password. Let me. I forgot the password. Let me see.
I think Yamuna 123.
Yes. No. Okay. See here you can give the title for the token. Anything you can give. You can set up expiration date, or also you can customize it also. Okay. And then you can give the access. So if you use the token we are using for which operation? For repositories, for pulling, pushing, all this. If you want to do all these things, you can use this one. For workflow usage, you can click this one. Okay. For writing packages, deleting packages, admin kind of things, if you want to do these things, you can click. Okay. So whenever you click any of these, you can use the token for this only. You cannot perform these operations with the token, because you are giving access to this admin only. Okay. So based on your requirement, you can select all these things, so that with the token you can access all this. You can do all these operations. Okay. Because you simply generate the token, the token will be created, and you can save that token somewhere safely. Or else you can create one more if you want. You can create, no issue. Okay, but keep it safely. Okay. So this is what
Okay.
token. Yeah.
So tokens, we have a big number and letters, right?
Yes.
Can we optimize in one single password? So every time we can use that password, right, instead of token.
Maybe there could be a chance, but it is by default, it is auto generating. I
Okay.
think we can do that. Maybe you can check the command. How can
Because every time people are using pull or push word, sometimes they can't use the full
yeah,
password, right?
that is
So they
that
can
yeah, that is the use of the token, because if you can resize it, if you can concise that token, that that will increase the risk, right? The token, what is the use of the token? It will encrypt your credentials. Simply, the token doesn't mean like it is not anything else. It doesn't simply, it will encrypt your password. Tokens means it's
okay.
encrypting your password.
But anyhow, before generating the password, we can uncheck the admin check, because when using developer, right, they cannot delete or any request. So in
Uh-huh.
that case, also it will be security purpose, right?
Yes,
We can
yes,
uncheck that admin,
yes,
then we
yes,
can create the password,
yes.
then we can give that password to the developers. They can
Ye-
only do the pull and push alone.
Yes, yes, you can do. You can give the fine grain access. Okay, you can give that. You should not give the complete access. Okay, for the token. As the administrator of this GitHub, you should have the access, complete access, but not all the guys. Okay.
Okay, but we
Anything?
can create multiple tokens also.
Yes, you can create multiple tokens.
Okay,
Okay.
okay, Rama, fine.
Yeah, fine, fine. Anyone else?
And can you go that last PPT, that hotfix you said, right?
Last one, right? This one.
Yes, yes, yes.
Yeah.
See, the developer last they are these are the these are the main commit they are doing. After that, the sprint will be gone. Then the version will be come under V1.0. Okay.
Yes.
Uh, so if we do the initial hotfix, the hotfix change will be performed in V1 also, or it will be uh, in lower branch only.
See, here, first of all, this version we have already added to the master. Okay. Now the master has the version 1 currently, right? Now, if you do hotfix, that means what it will have? This hotfix branch will have the code of version 1, right? Now he will do some modifications on version 1. Now again, what he has to do? He needs to again commit it. Okay, he needs to again commit it. If you want to again add one more version, you can add version 1 v 1.2 1.1, like that you can add it, but you will be working on version 1 only.
Okay, so whatever it is in the latest version, the hotfix also will be there.
Yes.
But the hotfix will be generated from the main branch only.
Yes, main branch only.
Okay, I got it.
Okay.
Okay.
Anyone else?
Yeah, for Git work, Ramana.
Yes,
For Git workflow, we are having only centralized workflow or some other.
Always we will follow this one only. The whatever the last slide I have explained, we will follow this one. Most of the times, 90% of the times we will follow this one. I think no one will follow the centralized one. No one will follow that, because that will not be useful for the complex projects. Okay. And also here, if you see, they will customize a workflow as per their need. Here you can see there are multiple branches, right? Maybe sometimes they may work on all the branches, or they may not be work on all the branches. Maybe sometimes they don't need hotfix. In that case, you can skip this one. Sometimes they don't need release branch. Simply they can create the version from the develop to master branch also, because they don't want to create, they don't want to make it complex. In that case, they will skip some branches. Whether, see, it is your choice, it is the organization choice whether they need to use multiple branches or simple branches like 2 to 3 branches, feature, develop, master. That can also we can form. But this is the whole structure of the branching stacks. So these are the branches we will have generally. Okay. So anything else?
Okay. Then, so you'll be using multiple masters in this. Multiple master.
No, Ram Kumar, don't use a multiple masters. Even it will not permit. It will not permit. See, whenever you have a branch name called master, again, if you try to create the name with master, it will not create. It will give you an error. Okay, so it won't create. But you can have, see, you can give master 1, master 2, master 3, like that you can give. But with the same name, you cannot create other branch. And in any organization, you should have only one master. You should only have one QA branch, one pre-prod, one staging, and you should have multiple feature branches. This is the way you should have, because if you have multiple masters, then where we can keep our latest, our refined or our finalized code, where we can keep in the master 1 or master 2. So everyone will be confused whether we need to follow master 1 or master 2. Everyone will be confused. So you should have only one master. Francis, do you have any questions? Anjali? If you don't have any questions, we will go to the talker. Francis, please ask.
Okay, no problem. You can go ahead.
Okay. What about Anjali? Okay. Let's start the Docker. So first of all, I need to ask you one question. Okay. So in the first class of Git, I have explained you about the DevOps. Why we need DevOps. I have explained why we need DevOps. So did anyone remember that one? Why we need DevOps? Already we have the agile methodology, and again we came up with the DevOps. Why should we need DevOps again? Because agile methodology will solve the issues between the client or the customer and the company. Okay, but the DevOps will solve the issues between inside of the company. I have explained this one. So did anyone remember this thing? Why we need DevOps? Because with this Docker we are going to solve these issues. Okay, we are eliminating all these issues from the whatever the issues we are facing before the Docker, before the DevOps. Those issues were almost we almost like 50 to 60% we can eliminate with this Docker. So that much important this Docker is, very important. So if you are not able to perform the Docker operations, that means you cannot do any DevOps task. We cannot call it as a DevOps guy. You are not a DevOps guy if you are not able to do Docker operation. Git can be, everyone can do. Testers can do, developer can do, DevOps guy can do, anyone can do, because Git is mandatory thing for everyone. But the Docker is the only thing. It's mandatory, very very mandatory for the DevOps guy. Okay, you should be very very clear in this Docker concepts. See, the Kubernetes will depend on Docker, Jenkins will depend on Docker, all the pipelines will depend on Docker, everything will be depend on Docker. Everything. This is the base for the DevOps. Okay. So, okay, I'll explain you why Docker. Why Docker? Why we are extensively using this Docker? Because whenever there is, for example, let me open my notepad. See, I already explained you this concept at the beginning of the Git session. I'm explaining you once again. See, whenever there is an organization, in that organization, if we take there are some developers and the operations guys. Okay, operations guys. Now developers will develop the code. Okay, they will test it on their local machines. Okay, if everything goes well, then they will give this code to the ops guys, operations guys. What these operations guys will do, these guys will test it again. If testing means not like what the testers will do with the test selenium and all these things. This testing means it's a different thing. Okay, so they will do testing. Okay, how they will do testing? Simply, if it is a Java code, for example, if it is Java code, what they will do? They will simply use Maven. Okay, they will try to first build that whatever the source code he has, he is try to build that one, and then he will just use the Maven testing. We'll simply use the Maven testing for the tester code while building or before building and after building. You can do testing. Before building you can do, after building you can do, during the building also you can do. Okay, so this is okay. So ops guys will also do the testing, but before that, see, this code will work if this code have the proper dependencies, proper OS, okay, proper libraries, proper binaries, proper software packages. Okay, if everything is good, if everything is supporting properly to the code, then this code will be executed. Okay, so here the developer will do all the test cases on their testing machines. It will work perfectly because he knows what are the dependencies he needs to use, what are the packages he needs to install, what are the libraries, what are the binaries, what are the OS, what is the OS, what are the software packages he needs to install. Everything he knows, so he can do all these things in his local system. But whenever he gives that to the ops guy doesn't know. Ops guy doesn't know this code. This code supports which OS, which software package, which dependencies, what are the dependencies we need. He doesn't know, but he always try to replicate the environment, what the environment he's using. The developer, for example, developer is using some environment. This ops guy will always try to replicate that environment. Okay, so while replicating that environment, he will face some issues because he may not install some dependencies. He may forget those things. He may not install some libraries, some binaries. Okay, in that case, that code will not work in the operations guy's laptop. So he will think like, okay, this code is not good. I think there is an issue with code. Operations guys will think like that. But the thing is, there is no issue with the code because the code is working fine in developer system. The issue is with the environment. Okay, so to resolve that issue, we came up with a Docker. Okay, to resolve that environment issue, we came up with a Docker. If you see here in the PPT, the developer, he is trying to deploy the PHP application. So what he needs that OS, he needs the proper OS, he needs PHP software, and this is the PHP code. He just written the code, and these are the libraries and the binaries and the dependencies. He will install all these things in this environment. This is one environment. Okay, this is this is one environment. In this environment, he will do all these things. Okay, so after some time, if he gives that code, this PHP code, this PHP code to the operations guy, operations guy may install or may not be install all these things in his environment. And also sometimes he may not install the proper version of the PHP. Sometimes versions will also create a lot of issues. It may be compatible or it may not be compatible. If it is not compatible, that version, the operations guy cannot do his operations. That could be the issue also. So we should eliminate that environment issue. Okay, in that case, how this Docker will resolve this issue? Simply developer will do all these things in his environment, and then what he will do is he will just wrap up. He will simply wrap up this environment. Okay, simply he will just wrap up. See, if you take the chocolate, what chocolate will how it will look like? At the outer side you will have some cover. Inner side you will have one more cover, and at the local, and you can say that at the core you can see the chocolate, the actual chocolate. Okay, the actual chocolate will be in the core. After outside you can see the wrappers, right? See here, similarly we are wrapping up the complete environment. Okay, we are wrapping up. So developer will always he needs to wrap up all the things, OS, software, code, libraries, dependencies, all these things he needs to wrap up. So after wrap up, he will give the complete thing to the operations guy. Operations guy will check. Okay, he don't need to. He just simply run that container. Simply run that wrapper. He don't need to execute that. He just simply deploy that thing to the servers only. He doesn't work on that environment part. Okay, so it will almost eliminate the issue of dependencies and all these things. Okay, so developer guy needs to wrap up all these things. Okay, see here, if you see the second slide, why use Docker? Easy to install and run software without worrying about setup and dependencies. Okay, operations guy doesn't work on that part, because developer will always give that directly. Simply he will give, and operations guy will take that one and he will simply deploy it. You don't need to do all these things. Okay, so and also run software in isolation without having side effects on other software running on machine. So if you are running any application without this Docker, there may be issue of the dependencies. There may be a overlapping with the other applications. For example, one application is running on some port. Let us take, if one application is running on 3000 port, and again if you are deploying one more application, that application is also running on 3000 port, that will cause an issue, because two applications should not run on same port. There should not be any overlap. So to resolve these issues, we need some isolation environment. So this Docker will create that isolation environment. Whatever the application you have, that application will be isolated from the remaining environments. There will not be any link between other environments. Okay. Now, see, what is Docker now? I think you have understood what the Docker, why we are using the Docker. Let us see again. Docker is an open source platform. Okay, we don't need any premium for this Docker. Okay, and the ecosystem designed to simplify the development, deployment, management of applications using containers. See here, the Docker will follow the concept of containers. You will listen this word multiple times from this class till the ending of the DevOps class. You will listen. Okay, you will listen this container word lot of times, multiple times. The whole DevOps will be running around this containers concepts only. Okay, so here with this Docker, we always create the containers. Okay, this container will contains the OS here, whatever I have showed you here. This is the container. You can say this is the container. Whenever you wrap up all these things, that will be the container. Okay, so that container will have the OS, that will have the PHP software with a proper version. It will have the code. It will have the libraries, binaries, dependencies, all these things. So that container will have all these things. Now that if you give that container to operations teams, he doesn't need to work on that container because that container is already wrapped up. We don't need to do anything there. We don't need to change anything there because that is working fine. Everything is set up there. Okay, so that is what container. Okay, so containers are lightweight, portable, self-sufficient units that package together an application and its dependencies, including libraries, configurations to ensure consistent and reliable execution across different environments. So I think you understood this point. Okay, see, I'll show you. Before learning about the containers concept, we should know what is virtualization, what is the virtual machine, what is the difference between virtual machine and the container, what is the containerization and the virtualization. Okay, so these things you need to learn. Okay, so give me 1 minute, guys. Okay, see, now I'll try to explain the architecture of the container. Okay, so after that we will discuss the difference between the containerization and the virtualization, and the difference between the container and the virtual machine. Okay, see here in this is the hardware. Like if you take your laptop hardware, this is okay. On top of this hardware you will have the operating system, like it could be Windows, it could be Ubuntu, it could be anything. Okay, so on top of operating system you will install the container engine. Okay, so this container engine can be Docker. Okay, or it could be Rocket. There are a lot of container tools. Okay, so currently the most popular tool is Docker. We are using the Docker. That is the most popular tool. But there are multiple container engine tools. Okay, so you need to install that container engine on top of your operating system. Okay, so whenever you install your Docker, this Docker will permit us to create the containers. Okay, if you don't have the Docker, then you cannot create. You cannot create the containers. Okay, see these things: application 1, binaries, libraries. These whole things, this orange and this thing, I think it could be some other color. I don't know this color is. See these two colors, we can say these two colors combinedly we can call it as a container. Okay, similarly this app2 and these binders and libraries, this is one container. Similarly these two, one container. Okay, that means this container have application code. Okay, and it will have the binaries and libraries here. Okay, and also it will also have the dependencies also. Here I'm not showing those things. It will have the dependencies, it will have the software packages. Okay, but you will get some doubt. You will get some doubt. In the starting slide here, I have shown you this container is also having one OS, right? Container is also having one OS, but if you see here what I'm doing, on top of the OS operating system, I have installed the Docker. On top Docker or container engine, on top of the container engine, I will create the containers. But in the first slide, I have shown you that container itself will have the OS. But this container is on the OS actually. If you see, this container is on OS. But in the first slide, the OS is in container. I think you understood, right? Okay. But the thing is, the container will not have OS actually. Okay. But here I have represented OS inside the container. But actually, the container will not have the OS inside of this container. So what will happen then? It will simply share the OS with this operating system. Okay, whatever the operating system you are using, okay, that OS will be used in this container, but this container actually will not have the OS. It will simply share the OS. It will simply share the kernel with the operating system. Okay, so that's why we don't need to install OS in the container. That means we are trying to reduce the size of the containers. If you install the OS in the container, that size will be very huge. The OS size will be around 2 GB, 3 GB. It could be, depends on the OS, the size will be increased. If you install the OS, the size will be very, very huge. So we are trying to eliminate all those things. We don't need to install the operating system. We simply share this container with this host operating system. Whatever the host operating system we are using on the hardware, that operating system will be shared with the container. And also one more thing, here in the container, we are not using complete binders and libraries. If you take the actual OS, that actual OS will have with the complete binders and libraries. Any OS, if you take the Windows, if you take the Ubuntu, if you take any Mac OS, every OS will have the complete binders and libraries. But in containers, it will not have complete binders and libraries. It will not have. It will only the limited. It will only have the sufficient things. If sometimes, if you need any other libraries or any other binaries, in that case, you need to install those things in the container. If you have the requirement, then only you need to install. Otherwise, you don't need to install. Okay. So those are the advantages of the container. That's why, because of this reason, the containers will be light in weight. The size of the containers will be very, very less. Because we are eliminating all those things. Okay. So this is the overall architecture of the container. Okay. Now, see, these are the benefits of the Docker: the consistency, portability, efficiency, isolation. See, Docker ensures the applications run consistently across development, testing, production. What it means? So here, if you go to the slide here, everything I have wrapped up as a container, right? Now this container we can run this container on any OS. Okay. See, regardless of this any OS, you can just simply execute. You can simply run this container on any OS, because this container already having all the things. Okay. Again, it doesn't require anything. It only requires the OS part. it will only share the kernel with the operating system, the base operating system. Okay, that is the only thing it will share. Okay, so whenever you run this container on any machine, it will execute. So it will, that is what consistency. Okay, so any server you can run it. Windows server, Linux server, any server you can run it. Okay, and any OS you can use. Okay, and the efficiency is very high. Because why? We are not using any unnecessary things in the container. We are eliminating all those things. We are only using the necessary things in the container. So that's why it is light in weight. Very less size it will have. Okay, it will share the kernel with the host system. Okay, so that's why we are using the resources very efficiently. So if, for example, if you want to boot up your laptop, your own laptop, it will take some time, right? It will take some time, around 1 to 2 minutes to boot up your laptop. So booting time will be very high for your laptop. But in case of containers, it's a matter of microseconds. You simply start the container. Microseconds. So booting time will be very less. Okay, and another feature is isolation. So everything is packed in the container. So why it will again needs to connect with other things? It doesn't require, right? We don't need that one. Everything inside the container, we should not connect with any other thing. So we are maintaining the isolated environment with the containers. That will give you the security. It will enhance the security. Okay, so those are the benefits of the Docker. See, this is the complete the Docker architecture here. Here you can see the three parts. Okay, this is the client, this is the Docker host, this is the Docker hub. Okay, so what is the client? The client means whatever the commands you are executing, that is what client is. Okay, client means you are just giving the input, you are requesting something, you are executing something. So that is what client. Okay, these are the commands: docker build, docker pull, docker run. So these are the commands. We are executing all these commands in the client. Like some command line will be there, some CLI will be there. In that CLI, the command line interface, we are executing all the commands. That is what client. Okay. Now, if you see this Docker host, this is the Docker host where we are going to install the Docker engine. Whenever you install the Docker engine, that means whenever you install the Docker, that will create one daemon, the Docker daemon. That means the daemon means the background. Okay, the background process. The background daemon will be created, the Docker daemon will be created. Okay, so whenever you execute the commands in the client, this Docker daemon will take those commands and it will do all the operations based on that request. Whatever the request you will give to the Docker daemon through client, this Docker daemon will take that request and it will do the operations. Okay, so what it will do, this Docker daemon, it will create the containers, okay, out of the images, and you will come up with one concept called Docker image. Okay, so this Docker daemon will just manage the images and the containers, and this will manage the networking part. This will manage everything about the Docker. This Docker daemon is the background process. Okay, now you don't worry about these images. Okay, I'll explain you. Okay, the whole Docker will be based on these images only. Okay, you will get to know everything about these things. Okay, Now after this, whenever you do these operations, like whenever you create the image, whenever you create the containers, you need to maintain one repository remotely. Whatever we have used in Git, like whatever we have used for storing the Git code for accessing, okay, if there are multiple developers, if that all the developers wants to access the code should be in remotely, in remote directory or in remote repository. Then only everyone can access that code, right? You should have some centralized repository, right? So similarly, like a GitHub, here we have the one centralized repository for the Docker images, okay, for storing the images, okay, so that every developer can take the image, every DevOps guy can take the image, every testers can take the image, okay, so everyone can access that remote repository. So in that case, we should have one repository, okay, so that repository will be connected to this Docker host. In this Docker host, there is a Docker daemon. This Docker daemon will be connected with this repository, okay. So in this in our curriculum, we are trying to see the Docker hub, okay. This Docker hub is our registry, our remote registry, our centralized registry, okay. So we are trying to learn this Docker hub as like GitHub, okay. Docker hub is similarly like a GitHub. This Docker hub will be used to store the images, Docker hub will be used to store the code, okay. So similar purpose, right? So here we are connecting this registry with this Docker daemon, and here you will get some doubt. Every time I'm using some word called registry and repository, I'm interchangingly I'm using these two words, registry and repository. What is the difference between registry and repository? There is a difference. It is a very important thing, like whenever you just a minute. See, sometimes the interviewer can ask you, what is the difference between registry and repository, like this they can ask you. So there is a small difference between registry and repository. I'll show you that, okay. So this is all about the architecture, okay, Docker architecture. Now let us see the difference between the Docker and virtual machines, okay. So previously before Docker, we already have the virtual machines, okay. We can do all the operations, like if you want to deploy the PHP software, PHP application in the server, what you have to do? Previously we were using the virtual machines for the deployment purpose, okay. But currently we are not using the virtual machines for the deployment purpose. Why? What are the drawbacks in that virtual machines? What are the advantages in the Docker? I'll tell you now. If you see, this is a virtual machine architecture. I'm just comparing those two things, Docker architecture and the virtual machine, okay. See, both the Docker architecture and the virtual machine, both the things will have some common points. Both will have the hardwares. Virtual machine will have the hardware, okay, and on top of the hardware we will have the host operating system in the virtual machine. In the Docker architecture also we will have the host operating system. Till now both are same, but from here onwards, if you see the virtual machine, this virtual machine will have the hypervisor, okay. This hypervisor, why? What is the use of this hypervisor? Very important thing, okay. This hypervisor will be used to create the virtual machines. You cannot directly create the virtual machines on the operating system. You should have the hypervisor on it. Okay, previously we have the one hypervisor called as like I think it's Zen hypervisor, I think, previously. So oldest one. Okay, currently we are using the Nitro. Hypervisor. Okay, so this hypervisor will be used to create the OS, and here you see we are installing the hypervisor on top of the operating system, but after installing the hypervisor, we are again creating the operating systems. See, OS, guest OS. See, virtual machines will always have their own OS. These virtual machines will not share the OS, will not share the kernel with the host operating system. Okay, virtual machines will have their own OS. We will deploy our application on that virtual machines. Okay, so because of this reason, virtual machines will be heavy in weight, because for installing the OS, it will consume a lot of space. The size of the virtual machines will be very huge when compared with the container, because the host size will be around 2 GB, 3 GB, it could be anything based on our choice, Windows or Ubuntu. So it depends on that OS, it will have the size. It will have all the libraries. If you are having the OS means, that means you will have all the libraries and all the binaries. That will also increase the size. Okay, so on top of this OS we will deploy the application. Okay, so here what I'm seeing here is the virtual machine size is very huge when compared with the container size, right? For example, I have an application. Okay, my application size, like, you know, my application will consume 500 MB only. Let us take for example, my application will consume 500 MB only, but the virtual machine size is around 4 GB, and we are using the 4 GB RAM. We are using the 2 cores, 2 CPUs. Okay, but we are deploying the applications of size of 500 MB just. It will consume only 500 space. Okay, so whenever you deploy that size of application, the remaining whatever the features, whatever the configuration setup we have in the virtual machine, the remaining everything will be useless, because the application needs only 500 only. We don't require remaining 1.5 GB, and the application requires only 1 GB RAM, but here we are using 2 GB RAM. Application requires only 1 core CPU, but here we are using 2 core CPUs. So everything will be useless, because we are not using that virtual machine efficiently. We are misusing, we are just wasting our infrastructure, our resources, because the application doesn't require all that much configuration. It requires less configuration. But what we are doing, we are virtual machines, like, you know, we will just, it's like a rigid in nature. Whenever you create the virtual machine, that will be rigid in nature. If you create the 2 GB virtual machine, that you cannot change. Whether you are deploying application or not doesn't mean. That is in rigid state. Virtual machine, we cannot change that. Okay, but see, because of this reason, we are wasting our resources. Because, you know, you need to pay completely for the virtual machine for that. we need to pay for complete virtual machine, not for the application, right? Whenever you create one virtual machine, you need to pay for the complete virtual machine. Whether you are using virtual machine completely efficiently or not, doesn't matter. You need to pay completely for that virtual machine. So you need to maintain the cost optimization. It's a very important thing. You know, cost optimization is very, very important. So here, if you use that virtual machine concept for the deployment and all these parts, even for the development part, even for the testing part, even for the deployment part, we cannot use that virtual machines efficiently. That is the main drawback of using virtual machine. That's why nowadays everyone is using the containerization concept, containers. No one is using that virtual machine. Of course, we are using the virtual machines for creating the containers, but we are not using the virtual machines for the deployment. Okay, got it? So this is what virtual machine. But here when it comes to the Docker or the container or the containerization, see here till now what I have explained, I explained about the virtual machines. See, this is called as a virtualization. Okay, this is called as a virtualization. Okay, if you come to here Docker architecture, this is called the containerization. I'm creating the containers, I'm maintaining the containers. Okay, this is what the containerization. Okay, this is the differences between the Docker and the VMs. Okay, and also one more difference I just forgot. There is a benefit of using the virtual machine. That benefit we cannot see in that containers. Of course, that feature is also there in the container, but still the virtual machine will dominate in that situation. What is that situation? In the networking part. In the networking part, the virtual machine will give you the proper networking, proper security. But when it comes to containers, it is somewhat less when compared with the virtual machines. Because, you know, sometimes you need to create the customized networking for the containers, for securing your applications in the container. But in case of virtual machines, it will give you the good networking part, gives good security. That's one of the best, one of the advantages over these Docker containers. Okay, see, that is the differences. Now we will see the Docker installation. Okay, so before going to Docker installations, if you have any questions till now, please you can ask me. Any doubt? Any doubt you can ask me till now. Ram Kumar, Francis, Solai, Anjali Singh, anyone, please, any doubt?
This will come as per the DevOps system. This will be coming after our Git, is it?
Yes, exactly.
Where it will be positioned?
See, I'll tell you that. Okay.
Hmm.
See, let me open my notepad. This is a good question. So where we use this Docker? In which position we use this Docker? See, developer will push his code to the GitHub, right? So the code will be in GitHub. Now what he will do, or whether it could be developer or it could be DevOps guy. Okay, what these guys will do, he will simply pull that code, okay, pull the code to the local machine. Okay, pull the code to the local machine. But in this local machine, we will install the Docker. Okay, now what we will do is, we will simply build the code. Okay, simply we will build the code. Whenever you build the code, it will create one image. Okay, after getting the image, if you run this image, you will get the container. Okay, whenever you access the container, you can simply access the application. End user can access the application. Okay, this is the flow. Okay, did you get?
You were saying build the code, right? For build the code, we will be using Jenkins there or Maven, is it?
See, Jenkins is the integration tool only. It will not build.
Okay.
Okay, it will
Okay.
not build. Jenkins will integrate with Docker. Docker will build it. Okay.
Oh, so it is a replacement tool for Maven, is it?
Yes, not a replacement tool. I cannot say. But I know. See.
Another tool or
Maven
same?
is another
No.
tool. Yes, Maven is another tool that is only for the Java projects. Okay.
Oh,
if you are using the Java code, then you
Ah.
can use the Maven. Okay. But
okay.
if you don't want to use the Maven, simply you can use the Docker. Even for Docker, even for Java, even for Node.js, even for Python, you can use Docker.
Oh, this is a universal one.
Yes, you can use this Docker for any kind of language.
Oh, okay.
Why it is universal? I already told you. Docker,
Open source.
No, not the open source.
No.
It is it will create the container. Container itself
Okay.
will have all the dependencies, all the libraries, all the software packages, it will share with the kernel, OS host
Okay.
kernel. So everything it will
Okay.
have. Why should it will depend on any other things?
Okay, got it.
Okay, yeah, fine.
Yeah.
So any question? Any other question, guys? Okay, shall I proceed?
No.
Okay, shall I proceed?
So,
Yes.
somebody is writing that YAML code, right? I mean, as part of DevOps, this will come under which area?
See, yeah, here if you see, YAML is a language. Okay, you can use that YAML language anywhere. But if you take DevOps, okay, in the DevOps you will use a multiple tools. Like if you take the Docker, we will use a YAML language. If you take the Kubernetes, there will also use the YAML language. If you take the ANSYS, you can use the Ansible. There we will use the YAML language. So multiple tools will use the YAML language. See, instead of YAML language, you can also use a JSON also.
Okay.
Yeah.
Okay.
Okay, so let me proceed with this Docker installation. Now, see, guys, you should use any cloud from now onwards. Okay, because without cloud, you cannot work with the DevOps tools. DevOps is a cloud native concept. Okay, because if you are using Ubuntu machine, like if your OS is Ubuntu, that will be the only one machine. But as a DevOps guy, you will work on multiple OSs. You will run the operations on multiple OSs at a time. But if you are using your local machine, your local Ubuntu machine, there is only one machine. So how it is possible? You need to work on multiple machines, right, at a time. So that's why you should use a cloud, any cloud. Okay. In that cloud, you can create multiple machines. Okay, you can create multiple instances, multiple EC2 if it is take AWS, we take AWS. You can create EC2 instances there, multiple instances. Okay, so you should always use one cloud. Okay. Now what I'll do is I'll simply our whole DevOps session will be based. I will use the AWS only. Okay. If you want to use, you can use other cloud also, Azure, GCP, and all these things. Okay. Now what I'll do is, let me go to my EC2. Okay, this is my AWS account. Oh, okay. Let me reload it. I think I will just stop this instance, or else you can use this instance also. But to understand clearly, I'll just let me stop this instance. I'll explain you clearly. I don't want to make you confused. Okay, that's why I'm just stopping this instance. I will create one more instance for the Docker itself. Okay, this instance I have created for Git. Okay, now I will create it for Docker. Okay, or else if you want to use the same instance for any tool. Okay, but just keep it in mind. This instance size should be like it should be based on our requirement. If you create the T2 micro instance, and if you are doing complex tasks, that it cannot perform efficiently. Okay, so based on your requirement, you need to choose the instance type. If you see here, you can see here I'm using K8 master, that means Kubernetes. For Kubernetes I'm using T2 medium for only demo sessions. Okay, in real time you will use different instance types. See, based on our requirement, I'm using I'm changing the sizes. Okay, you guys also please use sizes of the instance based on your requirements. Okay, now I'll create one instance for the Docker dreams. Let me take this name. I will take the Ubuntu machine. Okay, always try to get a basic knowledge on Ubuntu. Okay, because DevOps requires this Ubuntu knowledge. Okay, I'll take this 20.04 version of the Ubuntu. Let me take T2 micro instance type. Let me take the PEM file. What is that PEM file? Already I think I have created this Git PEM file. I don't want to create one more. I'm using the already I have created that PEM file, so I'm using that one here. Let me allow SSH. Okay, now launch instance. Okay, it is successfully created. Let me go to that instance. Still it is in pending state. We need to wait till it is in running state. Okay, refresh. Yes, now it is in running state. Let me take the public IP of it. Go to mobile xterm. Let me connect to that instance IP, and this is the Ubuntu. Take the PEM file. This is my instance 172.31.2.134. 172.31.2.134 private IP. Okay, now if you see, we need to install Docker, right? Okay, so first we need to check whether we have a Docker or not. Docker -- version. See, Docker not found. We need to install Docker, sudo snap install Docker, sudo apt install Docker IO. See, there are multiple ways to install Docker. There is no particular specific command to install the Docker. There are multiple ways. You can search in Google. You will find a lot of things, lot of ways to install the Docker. Okay, so I will use the simplest way to install the Docker. Okay, I will make your task easy. So if you go, if you search in Google, you can see multiple things. There are, there you can see we need to execute multiple commands for installing the Docker. But here what I'm doing is I will simply use the one command for installing the Docker. Okay, so before that, see, keep it in mind this one. Whenever you try to install any package, any software, first you need to update your machine. Okay, so I'm using Ubuntu machine, so you should use the apt package. Okay, apt package manager. If it is Red Hat machine, you should use M package manager, M, okay. If it is Ubuntu, you should use the apt package manager, okay. So first of all, let me install my machine, okay. I'm using apt package manager, okay. Apt get update. I'm updating my machine. It will take some time for updating the machine, okay. Okay, it is updated. Let me clear this one, okay. Now what I'll do is just simply use this command for installing the Docker, okay. Sudo apt get install docker dot io. This is the command for installing the Docker. Enter Y. Okay, it is installed. Now let us check the version. Docker hyphen version. See, now you can see the Docker version. Okay. Now let me open the slide. See, this is on Ubuntu I have done. If you are using the Windows machine, you don't have these kind of commands for installing the Docker. You simply download the Docker desktop. Okay, I'll show you what is that. Docker desktop. This is the Docker desktop. Let me open that one. See, this is the Docker desktop. If you are using the Windows machine, you can download this Docker desktop. Okay, you can do all the Docker operations here only without using the command lines. Without using the commands, you can simply use this UI, Docker UI. Okay, all the things can be done here. It will reduce your task. You don't need to remember all the commands. But I'm telling you, if you have a good knowledge on the commands, Docker commands, if you have a good knowledge on command lines, then only you can use this Docker desktop. But multiple times, 99% of the guys always use the command lines only. Only few people will use the Docker desktop, few people. Okay, but if you want to get knowledge about this Docker desktop, you can get knowledge of this. So very easy thing, very easy. So I don't want to explain about this Docker desktop, these operations and all these things. I will simply explain the command lines only, okay, as per our curriculum, okay. And if you want to go through this Docker desktop, you can go through. Very easy, okay. If you want me to explain, I'll explain you few things, and remaining you need to do R&D over this, okay. So this is what a Docker desktop. So how you can install this Docker desktop? First, simply you can go to install Docker on Windows. Simply execute it. You can go to first link, install Docker desktop on Windows. Click here. Here, Docker desktop for Windows. Click here. It will download you one file. See, exe file. You can simply install this file. That's it. That's it. Whenever you install that one, you will be launched with Docker desktop. Okay, so that is the way you can install the Docker desktop on your machine. Okay, for installing on Mac also the same procedure as like Windows. You just simply download any one of these. If it is Intel chip, you just click here, it will download one. Okay, one DMG file it will download. You can simply install in the Mac. Or if it is Apple Silicon, you can just simply here, it will download that one. You can simply install that in the Mac. That's it. you will be launched with the Docker desktop in that Mac OS. Okay, but 90% of the guys, DevOps guys, will always use the Ubuntu machine. So there is no use of having Docker desktop there. If you are using the Windows or Mac in your organization, then the Docker desktop is a choice, your best choice. Okay, so I'm suggesting you better to learn Docker desktop also. Okay, now, so the installation part is completed. Now if you see the Docker life cycle, so what are the operations you will do with the Docker? What you will do? Simply as like GitHub, here we are also having the Docker Hub. This is the remote repository or the remote registry. Okay, here you can see the cloud symbol, that means remote location. Okay, what we will do is we will simply pull, like in Git, what we will do, we will simply pull the code right to our local location, local machine. Here also we will pull the image, not the code, because Docker will always run around the images. Git will always run around the code. Okay, so Docker Hub will always have the images only, not the code. That's why we are trying to pull the image from the Docker Hub, our required image, to the local machine. After pulling that image, we will try to create the container. So we use the Docker create. So it will create the container. Okay, after creating the container, what we will do? We will start the container using the Docker start. So it will be started. Okay, if you want to stop the container, you can simply stop using the Docker stop command. So it will be exited. And again, if you want to start the container, you can again start the container by using the Docker start. It will be in the started state. And if you want to pass the container, you can pass the container using Docker pass. Okay, and if you want to unpass, you can use unpass it. Okay, and if you want to remove the container completely, then you can use the Docker run, Docker remove. Okay, so this is the life cycle. But here, if you observe, what I'm doing is I am pulling the image, I am creating the container, I am starting the container. But you don't need to do all these steps. You don't need to do all the steps. Of course, you can do that, but you don't need to do. Just simply use the Docker run command. This Docker run command directly will create the container, and it will also start the container directly. You don't need to use the Docker create, Docker start. This Docker run will create the container, it will start the container from the image. Okay, this is the life cycle. Okay, now we need to create a Docker Hub account. Like in the previous session, we have created the GitHub. Similarly, we have to create the Docker Hub here. Okay, how you can create the Docker Hub? You just simply go to type dockerhub.com. Okay, it will redirect to this page. Here you will have the sign up option, create sign up. It will ask you one email. You can give the email. You can give any username. Okay, you can give any password here. Okay, now just sign up. That's it, only 3 steps. Give mail, give username, give password, sign up. That's it. You will be launched to let me close this GitHub. You will be launched to you will be launched to sign in page. Okay, whenever you sign up, you will be here. So you will get here. See, it will look like this. Whenever you sign in into the Docker Hub, it will look like this. Okay, see, let me open the slide. So I think this is sufficient for creating the Docker Hub. I think I don't need to create that. you can create that Docker. It's very easy. So before executing the Docker common Docker operations, let me explain something a brief about the Docker Hub. Okay, let me open here. See here, this option, explore option. If you click here, explore option, you will see lot of images. You can click to, you can see multiple images. These are all the images. Okay, let me go to one. See, Alphen is the image, Nginx is the image, BusyBox, Ubuntu. These are all the image. What image? What's the meaning of image actually? This image actually, I already told you in the first slide of the Docker, the container is the wrapping around our requirements like OS, packages, dependencies, application, libraries, binaries, all these things will be wrapped up. Okay, see, whenever you wrap up all these things, that will become the image. When you run that image, you will get the container. Okay, previously what I told you, when you wrap up these things, it becomes the container, right? So there is slight difference between the container and the image. Okay, for your understanding, I have told that is the container, but actually that is not container. Whenever you wrap up all these things, that will become an image. When you run that image, you will get a container. That's the difference. Okay, the image and the container, that's the difference. Image is, it will wrap up all things. Container, when you just run the image, you will get the container. Okay, but here you can see these are all the images. This if you take the Alphen, this Alphen will have all the dependencies, all the necessary things in that image. Everything will be wrapped up. Okay, that is what this image. Similarly, Nginx. Okay, so why do we need these images? You don't worry, I'll tell you why we need these images. Okay, here if you see, you can download, you can pull, not the download, you can pull any image. Okay, how? Let us take Nginx. Let me click here. See, you can pull the Nginx by using this command, docker pull Nginx. Okay, so what are the tags it has? Nginx tags. What are the tags it has? It has all these tags. This image. Okay, see, these are all the tags with the versions. Okay, mainline Alphen, one Alphen, mainline Alphen third. Okay, these are the versions. Okay, and it will show you how to get the image, how to run the image, everything it will show you. You don't need the proper knowledge on, you don't need the prior knowledge on this. You just simply come here, Docker Hub, just execute these commands, execute it, just simply execute all these commands. You don't need that much knowledge on these things. Okay, but you should know the workflow, how to do those things. If you have a doubt, you just come here and you can check how to do that. It will give you all the things. Okay, and again I'm telling you, don't need to be expert in any tool. If you want to be expert in any tool, you need to spend 2 to 3 months for one tool. But as a DevOps guy, you don't need to be expert in that. You should know the workflow. You should know how you need to use the commands. That's it. That's enough. You don't need to be expert in that. Okay. So there are multiple things to learn about any tool. Lot of things. No one knows all these things, but you should have a basic knowledge on those things. That the main concept you should know. Okay. Now, so this is what the image. Okay, see, 1 billion plus downloads, 1 billion plus operations I have done on this Nginx, 1 billion plus. So that much popular it is, you can see. Okay, these are the versions. These are for the reference purpose. Okay, you can read everything here. You can follow this document and you can do your operations. Okay, if you see, there are two options. One is official image, other one is customized image. Okay, here I have checked. Here, see this one, check mark. Here I click this Docker official image. That means I will always get the official image only. These are all the official images. These are all the official images. You can see Docker official image, Docker official image, Docker official image. See this tag, you can see the tag. These are all the official images. Okay, but if you want to see the customized things also, okay, see verified publisher, click this verified publisher, you can see the verified publishers. These are the customized things. If you want to contribute your image to Docker Hub, you can also contribute. You can also simply just push your image to Docker Hub. Your image will also be reflected here. You can also be a contributor for this. So these are all the contributors. Okay, these are all the images, customized images, not the official images. Okay, so those are the things you need to see. Okay, repositories. If you click here, repositories, here you can see your repositories. Whatever the images you will push to the Docker Hub, those things you can see here. Okay, whether you are publishing or whether you are pushing your private images or your public images, everything will be, you can see here. Okay, everything you can see here in the repositories. Okay, the organizations here, if you click here, organizations tab, here you can create one organization. Okay, in this organizations you can create a project. In that project you can create a repository, similarly like a GitHub. I already explained you about this organization and the project and the repositories in the GitHub. It is same. Okay, same, almost same. Not almost, it's everything same. The concept behind is same. Okay, so I don't want to explain you again organizations and repositories. Okay, so if you want to create the organization, you can create. Okay, so this is all about the Docker Hub brief. Okay, so there is nothing to explain about this Docker Hub much in that. There is nothing much in that. Okay, if you want to explore here, you can explore. Okay, see here, you will see the architectures. If you want to get a ARM, you can click here, you can see the ARM images only. If you want to get ARM 64, you can see those things. If you want to get x86, x86 64, those things you can see. So based on requirement you can select. But if you want to Linux operating systems image, if you want to Windows operating system image, you can see that. See here, they have specified Linux. Okay, see if you click the Linux, it will show you Linux based images. Okay, see here it is Windows, Linux. If you click the Windows here, it will show this one also. Okay, whatever the operating system it contains, image contains, those operating systems we can sort out. We can search those things from here. Okay, and these are the extensions. Okay, I think these things are not required for you. No one will work on these things. Plugins, if you want to use the plugins, not important. These things, explicit plugins. No need to do R&D on these things. Okay, so just your task is to pull the image, push the image. That's it. That's it. Nothing much in this. Okay, so this is all about GitHub. Now let me open my slide. Now we will do some common Docker operations. Okay, so guys, let us take a short break. Okay, we'll be back after 20 minutes. Okay, So we will start the session at 1 o'clock. Okay, now let's take 20 minutes of break. Then we'll start the common Docker operations. Okay, so till now, do you have any questions? Till now, do you have any questions? If you don't have any doubts and any questions, we'll go for break and we will resume the session at 1 o'clock. Please let me know, any one of you. If you don't have any doubts, we can just we'll go for break.
Okay.
Yeah, Franz. Okay, fine. Okay then. Okay, guys.